Well, hi folks. Uh, Today we'll see something about Llmnr poisoning and how to access credentials of users using a tool called Responder. So first things first, uh, today we'll see about how this Llmnr poisoning works and followed by a live demo of how actually we can capture these credentials of a user and crack them using a tool called Hashcat. So first things first, well, there are a lot of attacks in Active Directory itself. Lmnr poisoning is one of an initial attack that could be done under Active Directory. However, there are so many attacks and so advanced attacks that could be done on an Active Directory environment, which are called post-compromise attacks. However, today we are only going to look at the initial attack vector called Lmnr poisoning, considering a scenario wherein we are in an internal pen test and we are only given access to this network. However, we do not know the network map. We do not know how many systems are running on the network. We have just been dropped inside the network and we will make our way inside this network and bring out the hashes and crack them. So let's go ahead. Well, but before that, who am I? I am Ahmed Husamuddin, an IT professional and a cybersecurity enthusiast, and I have a clear understanding of ethical hacking and penetration testing. So what is an Lmnr? Well, an Lmnr is nothing but a Windows service. It stands for Link Local Multicast Name Resolution. So what it does, it actually does a task of serving as a DNS when a DNS actually fails. So whenever a query is been asked to DNS server, if DNS fails to resolve the query, LLMNR in place of DNS works as DNS and try to resolve the query. But the key flaw with this LLMNR service is that whenever you respond to this service, it actually responds back to you with two important things, which are a username of the machine and also the password hash, which is extremely bad since attackers can use the password hashes to carry out many attack vectors from initial attack vectors to advanced attacks as well. So let's go ahead and see an overview of this attack, of how this attack actually is carried out. So with this picture depicted, we can easily understand how LLMNR actually works. Let's just say in an Active Directory environment, they have file shares on the server. Let's just say a user is using a file share from the server. So the user will definitely try to connect to the file share. And sometimes because of the typing mistake or the typo of the user, the DNS fails to resolve. So this is what we are going to take advantage of. So here, a user is trying to connect to a hack me server. Let's just say the name of the server is hackme, and the user is trying to connect. But because of the typing mistake, what happened is the user only typed hackm. Now the DNS will obviously fail to resolve such query because DNS doesn't know the destination address of this server. And what it does, it actually asks, or you can also say in technical jargon, that it actually broadcasts a message to ask whether anybody on the network knows the destination or the route to reach to this hackm server. Then we, as a man in the middle, obviously could exploit this thing. And how we are going to do it? Since this is a kind of man in the middle attack, what as a hacker we could do is that we could just listen in between this communication, and whenever the broadcast message gets to us, we can poison that Lmnr broadcast request, and we could ask the destination user or the server to send their hash and username so that you could connect to that server. and the victim is like, okay, here you go, here's my hash and here's my username, and we are like, boom. The next few slides will easily explain you the attack. So what I have actually done is I've actually segmented the whole attack in 3 simple steps to make it more understandable. So let's go ahead and understand that. So the first step, what we could do is we could use a tool called responder for that. And what is a responder? A responder is just a tool written in Python language which responds back with a poison messages or poison requests. So as to get the password hashes and whatever the credentials that is lying on the system. So this is the first step that we could take by launching the responder in an attacker machine and just sit down and listen on an internal environment. Then an event will occur. The event could be anything, such as uh, being a typo or typing the wrong address or searching for a wrong network drive as well. So for ease of operation and for ease of understanding, we could just point while doing the demonstration, we could actually point directly to an attacker machine just to see how dangerous this attack could be. So, so because of this event, what actually is waiting for us is the actual password hash of the user. So whoever the user was, we were able to capture a hash of this user. We can get this hash. Let's just say here it says the domain name is Michelson and the username is Bex. And the IP address of this client system is 192.168.81.129. So we could actually get this hash, take this hash offline, and we could crack them. So another step and the final step to this is cracking the hash. And we can use so many tools, so many versatile tools are available online. And also Hashcat is built in Kali Linux. And also you can use John the Ripper. You can actually apt-get install and use that tool too. So we could act, so can you can actually see that I have taken up this hash and passed this hash to Hashcat and got the password. So this password was very weak, so it was very easy for Hashcat to actually take this hash and crack it. So I have also have demonstrated an example, as you can see, about an administrator user, domain administrator, which is a very big thing as from the privilege perspective, that I've actually taken the Michelson's domain administrator and I got its hash, and also I was easily able to crack that hash using the Hashcat tool. So before going further, I would like to explain you the actual setup of a network that I have prepared on my lab to demonstrate this attack. So on our network, we'll be having an attacker machine, which is actually having the responder, which definitely is a Kali machine. And secondly, we are having for as a victim machine, we are having a Windows 10 Enterprise version machine running on our virtual machine as a virtual machine. Definitely, we also have a Windows Server 2022, which is the latest version of the server serving to this client machine. So let's see how this attack actually works. So I actually have these 3 machines running over my system. So let me just get these machines are running. 2 of them are actually running. Let me just take this machine and run to. So here in the Kali machine, as I log in, you can see that I can actually go to this terminal, and as a first step, we could actually run the tool responder. So how to set up a listener using a responder? Here you go. Here is how it's done. So I could actually use a sudo before using a responder, and actually using the term responder. Since this is an in-packet tool, it comes under in-packet toolkit. So if you are uh, interested in performing the same attack, you have to have the in-packet tool. You can get it on GitHub or online. You can search for that tool. So sudo responder and -i is for the interface that we are using. We're actually using interface ETH0. Let's just check what is our IP. ifconfig for that. Okay, ifconfig, you can see the network adapter we are using is on ETH0, it is capturing. So we want to run the tool on this network adapter. And our IP address is 192.168.81.130. So here you go. And that is ETH0 is for the interface part. And then we could actually have an option RDWV. It is for verbosity purposes and for ease of poisoning. So let's just go ahead and hit enter on this one. Let me put the, yeah, it is actually listening for incoming events. What is important here to understand is that when I start this tool, it actually starts 3 to 4 poisoners. Here, Lmnr is one of them. And if Lmnr poisoning doesn't work, it will go to nbt-ns. And if nbt-ns doesn't work, it will go to DNS or MDNS or so on and so forth. Similarly, what we can actually observe is that there are multiple servers also running. So servers are also running like SQL server, SMB server. If anybody tries to connect it, we could send poison requests to them. So it's like intercepting, sitting in the middle of the communication. Since we are on the same network, it will be very easy for us to capture the traffic and send the poison requests. Let's just say there is a user called Rebecca. And by logging into this user machine, we are going to show you that how a small mistake of user can lead to the leakage of password credential and sometimes leads to account takeover. Let me just or we could sign in with some other user. Let's just say we enter with the domain user, with the domain administrator. The password would be let's just say we have logged in using a local administrator on this machine. And here also the Windows 2022 server is also working. Let us just log in this server just to show you how it's going to work. So this one, as you know, is a server and this one is a client enterprise version. So now here in the Kali machine, we are waiting for an event to occur. An event could be anything. It could be a typo by a user in Active Directory environment, or it could be pointing towards a wrong network drive as well. Because sometimes they have in Active Directory environments, you have the file shares, the SMB shares available for the users and employees to use. So just to prove the concept, what we can actually do is that we can just on the file explorer, wherein we could actually point directly. Let's just say we're trying to point for ease of operation and for ease of explanation and to demonstrate this attack easily. We are directly pointing towards the attacker machine just to see what happens. I believe my attacker machine's IP is 192.168.81.130 if I'm not wrong. Let's just say we're hitting enter and see what happens here. Here you can see easily that I have done nothing, but just because of a small typo, because of the user's mistake, it was trying to access the wrong server and we were successfully able to get a domain administrator's username and a password hash. Here you can see from here onwards, there's a username, there's a domain name, and the password hash which we got through an SMB server's poison request. This way, we could actually get the hash. So next thing, what we could do using this is that we would actually get this hash offline. What we could do with this is, let's just copy this hash. For instance, yep, I'm copying it. And let's open another terminal. And let's just do nano ntlm1.txt and let us paste this hash over here. Since we have pasted this hash, let's save this file. Let's just do another time. Yeah, we have saved this successfully. So what we could finally do is that we can just take this hash, pass it to tool called Hashcat or John the Ripper, whichever you like. Like for example, I'm using a tool called Hashcat. Okay. And in Hashcat also I'm using a module number 5600 and I'm actually passing the nano file that we actually created for the hash and followed by the rocky.txt file. Now what is this rocky.txt file? It is nothing but a word list that contains millions and millions of passwords, as you know, and pass it to this command. And what you could do is just -force you can do, which will actually use whole of your CPU, because cracking passwords is a very heavy task and it requires GPUs and CPUs. So consumption of CPU will be there, and sometimes the performance of the system reduces. So that's why I'm not doing the -force. I'm not forcing to use my CPU completely. And also I'm adding an option called -o, which means to optimize this attack. I mean to optimize this password cracking. So let's everything is perfect. Let's just hit enter and see how whether it will crack this hash or not. Yeah, it says Hashcat starting, applicable optimizers, watchdogs. The host memory required for this attack is 64 MB. And yeah, perfect. I think it's trying to crack the hash. Let's just see whether it will crack the hash or not. I'm sure it won't take too much long because a processor can compute and crack the hashes, millions of hashes per second, and per minute it would be millions and millions of hashes. So it won't take much longer, I believe. So here you can see that the Hashcat came back with a cracked hash. Let's just say what's it saying? It is saying status cracked. Hash name was anti-ln version 2 hash. And what you could actually see is that the hash has been cracked and the password for this domain administrator is password. Look how it easily cracked the password without actually having the network credentials of any privileged user, we were easily able to take the administrator's hash and crack it easily. This way you can easily get a foothold in the network, and there are lots and lots of other attacks which you could also do. And for in this example, we saw that it was very easy to crack the password hash, but sometimes the password hash doesn't be cracked. Sometimes it won't be cracked very easily because of the password complexity or because of the password policies the uh, company keeps for its employees and users. So in what we could do in those cases is that we could actually use advanced attacks like taking that hash and passing it to the another user called password relay attacks, and you could easily do that with some other tools, and you can also use responder for that, but that is out of the scope for this webinar. There's one last thing which I would like to explain to you guys, and which is the mitigation strategies for this. It is believed that nowadays the organizations are taking the great precautionary measures in order to save themselves with this attack. However, it is also reported by uh, all the pen testers that 70% of the Active Directory environments still use this Lmnr service, which is very vulnerable and which is very dangerous. It could easily be abused. So here I came across an article on Lmnr and nbt-ns poisoning, which you could use to practice this attack as well. And what I found here, which is very interesting, is that how the mitigation strategies actually work. Here are the mitigation strategies which I wanted to share with you guys, and which are the first and the foremost is disabling Lmnr. And here the commands and the actual directions for disabling the Lmnr is there, and also disabling the nbt-ns services, which is net bias name services. So Lmnr was previously used to be known as nbt-ns services. But sometimes in case of companies saying that no, we have to use this service to run our business, in that case also what we could do is by using this kind of mitigations like SMB signing. If the SMB signing is there, relay attacks won't work. Also, network traffic filtration is there, so it won't just give access to anybody on any port for any service. If it will see the MAC address of the incoming request, if the MAC address is valid inside the internal network, they will give access. If not, what they will do is just shut down the port. So that was all, guys. I hope you understood the concept of Lmnr poisoning, and hope you guys like this uh, video. If you like it, please do share with your friends, and also this will always be available on the VIH group. I made this video since this was a part of my internship program at VIH group. So that's it, guys. I'll see you in the next video.